Welcome to Dear SQL DBA, a podcast for and about SQL Server database administrators. I'm Kendra Little. This week, our question is about the unexpected happening after you upgrade your SQL Server. What if performance gets worse? Here is our question. Dear SQL DBA, I recently went through a process of migrating databases from a SQL Server 2008 R2 standalone instance to a SQL Server 2012 Service Pack 2 cluster. The cluster servers and SQL Server configuration were built to be as close to identical to the old instance as possible in terms of memory, cores, disk, max stop setting, and cost threshold setting. But after the migration, I noticed that CPU utilization jumped from the normal 25% to a consistent 75%. I did several other migrations with similar server loads with no issues, so I'm a bit puzzled as to what might be going on here. Could the upgrade from SQL Server 2008 R2 to SQL Server 2012 simply be exposing bad queries that 2008 R2 was handling differently? Sincerely, unexpected performance regression. This is a great question, and I have to say the question was put in a very kind way. You called the queries bad, and you said maybe SQL Server 2012 is exposing the bad queries. Well, another way to say this that isn't so nice, because I'm not as nice as your reader, is could we actually have like an optimization problem in a higher version of SQL Server where it just isn't as good as optimizing a query? And the answer is yes, we can. I have found those to be somewhat rare, and I've hit a bunch of issues during upgrades, some of which are inside the SQL Server and some of which are outside the SQL Server. So I actually want to talk through the stories of this stuff I've seen causing problems with the upgrades and what I look for when I'm troubleshooting performance after the upgrades, because bad query optimization due to like a regression in the optimizer is possible, but it's just one of many possibilities of where things might go wrong. So here's like the long list of stuff I look through because of the weird stuff that I've seen in SQL Server when I'm upgrading. I do like to look at, especially if CPU has gone up, I like to look at what are the settings that I'm using related to this on the new SQL Server, and are they right? So you brought up the max degree of parallelism setting and the cost threshold for parallelism settings. Those are, especially if you're talking about CPU jumping up, if we accidentally left max stop on the new server to the default value of 0, meaning any query that goes parallel can use all the processors, and we had it set to limit more on the older instance, that could lead to the workload causing fighting over all those cores, and it could cause CPU to go up. Now, I don't think this is the issue in this case because the reader mentioned looking at those settings specifically. If you want to know more about how to set parallelism settings in SQL Server, just on the last episode of this podcast, Max Degree of Confusion, I talk about how to look at the hardware you have and use Microsoft's guidelines to set this. So I would actually look at all the settings in the sys.configurations dynamic management view and just review. Did I accidentally change some on the new instance where I didn't mean to? How do I have these set to the right values? Always really smart to sanity check those. I have had some cases where I had poor performance on the new hardware, and the issue was that it was a hardware bottleneck, but it only showed up after migration. Now, I'm talking about hardware stuff as well as upgrade stuff, just because when we upgrade SQL Server, usually we move to new hardware too, because if we just spend a lot of money on licensing, why run those new expensive licenses on slow old hardware? So usually when you're troubleshooting this, you have to deal with, like our questioner has, I have to worry about not only SQL Server stuff, but hardware stuff too. And I've had stuff go wrong with new hardware where the new machine looked fine before we moved into it. In one case, there was a high CPU case actually where the power source actually wasn't completely plugged in. And it's odd that this would reveal itself as a high CPU usage, but it did, because what was happening is the processors weren't getting full power, and they actually weren't running at their full clock speed. The processors were running at a lower clock speed than they could, and so it took less activity to actually use a high percent of the available processor power. This was apparent from some messages when looking at the Windows event log. This system log had some messages about power issues, and also running the free tool CPU-Z, you could see what is the actual clock rate that these processors are getting. So these free tools for looking at processor power, you have to make sure that you download the right free tool that doesn't include spyware. That's the hardest part, but you can actually check what the clock speed is on it. If you're concerned about running that, you do a change request and make sure it's all approved and stuff like that. Another thing that I've actually found following a migration, we had higher CPU load, and when we looked at Task Manager in Windows and looked at it by the individual core, one of the logical processors was pegged. And we were having weights, CPU-related weights in the SQL Server. So we started tracking down, look at what tasks are using CPU, and we figured out that it was actually the network card in the new server. It was under a high load from a bunch of different application servers, and the network card was just only using one little core to do all its work, and it was bottlenecking that, which was slowing the SQL Server down when it tried to use that core. We were able to reconfigure the settings on the network card so that it used multiple, it spread out the load and didn't just totally dominate and bottleneck itself even on one processor, and CPU weights went down too. But we hadn't seen that prior to migration, because most of our load tests, we ran small application load tests. We didn't have all those app servers, in the test environment. And then we ran activity inside the SQL Server, like from agent jobs. It didn't use the network card heavily like normal patterns did. So I have had cases where, just due to the nature of, high transaction stuff, the new network card had an issue that the old network card didn't have. And you have to look for that hardware stuff whenever it happens. You could also have power savings enabled on the processors. Now, I wouldn't expect this to make the difference between 25% CPU and 75% CPU, but it could be part of the issue. You could have multiple things, and this could be one component. This is not just related to the Windows setting for power savings. You want to look at, is power savings enabled in the BIOS? Because just changing the Windows setting doesn't actually necessarily change the server's behavior. To check this, you want a server configuration management tool. And you want the one that ships from the server's manufacturer. So for Dell, I think it's called Open Manage. My brain doesn't like to, when they update the names of these tools, my brain doesn't like to update them. So I think it's currently called Open Manage. I think for HP servers, it's System Insights Manager. But they let you see, first of all, warnings happening at the server level, which is always good to look for, but then you can also see the current BIOS settings. And these server manufacturers also ship white papers on how to set up the server. You want to find that white paper for your specific server and look up how to get high performance mode. Most of them call it high performance mode, and it still seems a little odd to me that our server might not ship with high performance mode on, because I don't know about you. I always want high performance, but with the power savings on, and usually there's 3 or 4 little settings about C states and stuff like that you have to change. With power savings on, it can cause it to be slow for your processors to actually churn up to full power, and it can elevate some of your CPU usage patterns. So you want to make sure that your SQL servers are always in high performance mode. It does usually take an outage to fix this, because you got to change the BIOS and reboot. I have had cases where I moved to the new version of SQL Server and we were getting either stack dumps that freeze up the SQL Server while the stack dump's writing out and then cause high load afterwards, or we were having intermittent high storage latency where we got these 15-second storage latency errors and SQL Server was essentially freezing up and then things were kind of backing up and having to move through afterwards. You want to check your SQL Server error log for these, and I would look through the last day, just look through all the messages, but then filter all the logs that you've got for the word stack dump. Do we have any messages with the word stack dump? If so, I want to go review that whole thing. Stack dumps are bad news. You want to, that's raising the red flag, hey, there's something really wrong. You also want to filter for the words 15 seconds to look for these latency errors. For more on these storage latency errors, check out my previous episode in Dear SQL DBA called Outside the Big Sandbox. I talk a lot about what those messages mean and why they can really kill your performance. Another thing I check for if I have poor performance after a migration is, am I really using all the CPUs that I think I'm using? Because there could be a licensing issue that I didn't notice where the SQL Server actually isn't using all the cores, and so the cores that it can use are getting much higher utilization when I look at those cores, but I may have a bunch of cores and maybe even entire chunks of memory that SQL Server can't access. This sounds really weird. It's actually, I've seen it more on SQL Server 2012 than other issues. So it's actually more predominant on SQL Server 2012 because of a licensing change. SQL Server 2012 was the first version of SQL Server where you couldn't do a per seat or CAL license for SQL Server Enterprise Edition. But for customers who had 2008 R2 Enterprise Edition and were upgrading, an option was available for them to upgrade, but to only use 20 cores. So there is a version of SQL Server 2012 out there that when you install it, it will not let you use more than 20 cores, 2020. So hopefully I said that number right. And what happens is if you, let's say you've got 36 cores on your SQL Server, if you're running this edition of SQL Server and you start it up, there will be a message in the SQL Server log that says, oh, I see more cores than this, but because of licensing reasons, I can only use 20. So it's very clear about it when you look in the message right after the startup, but you have to know to look for that message. And so I found this in some cases where like people didn't know that the licensing was going to work this way. And in that case, the fix was, since that was the licensing they actually had and what they paid for, the fix was to manually use CPU affinity to say, okay, well, I want you to at least spread out the cores you're going to use across all of my physical CPUs so that you can use those sockets and the memory associated with you, and it's more balanced than having you only use gang up on these couple processors. In another case, I actually found that someone had accidentally downloaded the install media. Because the name of the install media where they downloaded it on the Microsoft site, the name wasn't very clear that it was the 20 processor version. And they had actually paid for more processors, but all of their SQL servers were only limited to 20 cores on SQL 2012 because of that one oops on the download. So for them, I mean, the good news was they could reset things up, but it's kind of a pain. Another case I've seen this happen is in virtual machines. SQL Server Standard Edition will only let you use 4 sockets. So let's say you're going to give 6 virtual CPUs to your VM. Sometimes folks accidentally set that up as 6 one-core virtual sockets instead of setting it up as 1 socket with 6 virtual cores, for example. So Standard Edition is limited to 4 sockets. Again, if it's limiting the ones it can use because of a licensing reason, you'll see a message in the SQL Server error log right after startup, so look for that. Another thing I always look for is whether something outside SQL Server is using CPU and fighting with the SQL Server for CPU. Now, you've probably checked for this, but if you're like me, it's worth checking again because I have totally been that person who had a bright idea in the middle of the night way before we went live. And I was like, I can test this cool thing on the hardware we aren't using yet. and I set up some stuff that maybe I forgot to turn off. So look in the Windows Task Manager for what processes are using CPU and memory. Look at the scheduled tasks to see if anybody went into Windows scheduled tasks and set something up. Look at your agent jobs. See if there could be something running outside of what was running on the old instance that you forgot about, because I have totally been guilty of that. Another thing to check that might change during a migration is, are you using a new version of SQL Server's Cardinality Estimator, and is it different than what you were doing on the old version? Now, this is specifically for when you're upgrading to SQL Server 2014 and higher, because this new Cardinality Estimator was introduced in 2014. Check your database compatibility level. On SQL Server 2014, if it was raised to compat level 120, you turned on the new estimator. And the new estimator, I'm really glad they're doing it. It makes some queries faster. On some instances, some people have found that it causes regression in other queries. So you might be in that bunch of people. You don't want to just turn on the new Cardinality Estimator without testing it. And if you are using the new estimator and you're seeing query regression, you want to say, okay, are we having the same issues if we lower that back down? On SQL Server 2016, they've actually made it easier to use the older version because they separated it a little bit. You can set a database level setting called Legacy Cardinality Estimation. You can turn that on so that it lets you say, okay, well, I do want to have my compat level at 130, but I want to use the old estimator with this database setting. So you've got more options for configuring it on SQL Server 2016, which is fantastic. You can also use trace flags to turn this on and off on a per query basis. What I'm really saying is, if nobody tested using the new Cardinality Estimator before you did your migration, you probably want to turn it off and use the old one until that can be tested, because you're going to have some queries that it's great for and possibly some queries that it's not good for. Possibly. And it could be, like our reader suggests, that SQL Server is optimizing some queries differently and it's burning a lot more CPU. When I'm doing any kind of upgrade or migration, I like to have the old instance still available. So when I cut over, I use either a backup or restore method, so the old one's still there, and I always do the backup, no matter how I'm moving, right? Always do the backup. Or I do a log shipping cutover or a mirroring cutover if I need minimal downtime. It's perfectly fine if you need to shut the old instance off. Sometimes people like that just because then they know nobody's getting in there, but you want the ability to turn it back on so that you can say, hey, I've got this query behaving strangely on the new instance. If I run it against the old instance, do I get the same query execution plan? Does it take the same amount of time? Does it burn the same amount of CPU? Does it do the same amount of reads? So I like to keep the old instance around for at least a month, longer if people are really sensitive to performance and it's critical. So I always set a timeline on when we're going to get rid of that old hardware and say, okay, if we care about performance, having this around and at least available to power up is going to be really useful for troubleshooting. So for the same reasons, before I migrate, I like to pull the top 10 queries who are CPU users, save them off with their execution plans. The top 10 queries by who do the most logical reads, save them off, save their execution plans, and then the same thing for most frequent executors or frequent flyer queries, so that on the new server, if I'm looking at, hey, who are the top CPU users, I can quickly kind of see, is everything normal in Normalsville, or hey, is this using a lot more CPU than before or running a lot more than before? Saving off that stuff prior to migration can save you a lot of time after migration just by giving you that baseline of what is normal. If you didn't save off the queries that were running first, here's what I would look for. I would pull top queries by CPU. I'm going to tell you about a couple free tools that you can look for. And for those queries, I would look at, are they asking for indexes Or does the query that measures them show that their average reads is really high? Because it's possible the plan was using an index on the old version of SQL Server that it isn't using now for some reason, and it might be asking for something different. Is there a huge amount of executions per minute on it, and why is it running so frequently if it's one of the top CPU users? Maybe something's configured differently and a service is running like crazy now when it didn't used to. I have totally seen that happen on a bunch of different systems. Why is this running so often? And somebody's like, oh, that shouldn't be doing that, right? Or are there warnings in the execution plan? And warnings will be represented by a little like yellow like roadwork symbol. So look for those if you don't have the before to compare them to, and sometimes you can find something there. Tools to find the top CPU users for free. There's two I would look at. SP Blitz Cache is a stored procedure you install. It is totally free, but you do need to register your email address. It is from Brent Ozar Unlimited. That's called SP Blitz Cache. And then Glenn Berry from SQL Skills publishes DMV queries. If you search for Glenn Berry SQL Server DMV, you'll find his queries, and in them are top CPU users, and he has an Excel spreadsheet that you can paste the results in, which is useful as well. So both of those are totally free. That's SP Blitz Cache and then Glenn Berry's DMV queries. You could also have a new bottleneck just because the new hardware is faster. I've had this happen to me, and it was, you should see my face the time it was the most notable. We moved to a server with faster cores and a little bit more memory, right? That's great. It's fantastic. But because our queries became faster, SQL Server could keep more information in memory. It was better at caching, and the CPUs were faster. It just changed application patterns in a way that we went from having a small amount of blocking to a whole lot more blocking every day, just because queries running at the same time, the traffic pattern shifted. And we were able to solve this by tuning indexes and doing things, but it was funny because you move to this great new server and you expect victory, like, woo, everything's gonna be great. And then you're like, why do I have this weird new blocking? Now, the way that we detected this is we were taking samples of SQL Server's wait statistics before we moved and taking samples of them afterwards, and we saw that lock wait types went up. So we were able to see that and address it. I like to have these samples before and after migrations of wait stats. You can get a script for free from Paul Randall of SQL Skills. If you search Paul Randall wait stat script, he has a free script to let you collect wait stats. Or Brent Ozar Unlimited has a stored procedure called SP Blitz First, which will let you collect those wait stats as well. This stored procedure used to be called SPS Brent. It's been renamed, and you got to register for that one too. But it's totally free. So those two scripts will both let you do the wait stat samples. And looking at the wait stats is also useful because I've had some cases where I went to a new version of SQL Server and I just had a weird wait because the application pattern happened to hit this part of the code base that was different in the SQL Server. So in one case, I had these really high CMEM thread waits, which is a strange wait, and investigating it is like murky and deep and dark. It's like contention on memory objects inside the SQL Server. It's almost like you've discovered your SQL Server is having childhood trauma or something. And we were able to actually figure out a setting to change to make the problem to go away. It was this old version of SQL Server 2008 R2, and I don't even want to tell the whole story because then you'll be biased against the setting. But basically, look for weird waits. If you baseline the waits before the migration, you'll know what's normal for your workload, and then something anomalous creeping up, you're like, hey, what is this? Gives you something great to search on to try to track down that issue. These issues, I will say, are really, really pretty rare. It's very rare for me to upgrade to a new version of SQL Server and there's just like a bizarre wait taking over the server. I should knock on wood when I say things like that. I have had some cases too where the new server was just getting more load. The way that the question was sent in, the person who asked this question, it sounds kind of like they may be either a consultant or they may work with a large group of users and not like sit next to them. Sometimes we have these servers who get migrated to new hardware right before the busy season starts. People realize, hey, it's about to get busy. Let's actually make sure we're on good stuff. So that may have happened in this case. One of the ways you can tell is there's a performance counter called batch requests per sec. And the good news is almost every monitoring software in the world knows about batch requests per sec. It's been around in SQL Server a long time. But you can, if you have info from this counter before and after, you can see how much work were we doing before and has that gone up. Part of the reason CPU has gone up may simply be that we've hit a busy season and load has gone up, and batch requests per sec can help point that out. If you're just setting it up to collect those counters, it has two friends, compilations per sec and recompilations per sec. And those, if you compile, you use more CPU than normal. So those are also of interest too. Are we compiling more for some reason? So lots and lots can go wrong when we upgrade a SQL Server. If you're listening and you're like, hey, what is all the stuff that she just said? I've got a list written down for you. Go to littlekendra.com/DearSQLDBA and click on the link to this episode. And you'll see a checklist of all of that stuff I mentioned that like, yeah, I like to have this info before the migration to compare for your planning purposes. And also every scenario that I talked through today about what I look at to troubleshoot after the migration. Thanks for joining me for Dear SQL DBA. If you're enjoying this podcast, I would love for you to review the show on iTunes. And even if you're not enjoying the podcast, I would love to hear what you think. So please drop me a review, and I will see you next week.